So in question 6, we're given this curve which has this parametric equations. We need to find dy dx in terms of t. So in fact, what we can see here is that what we could do here is the idea we have here is that we have this function of y, but this is a function of t, right? But t here is a function of x. So if we could rearrange for t here, we would get like t is equal to like something something in terms of x, and we could plug this up over here, and then y would be in terms of x. However, we don't really have that equation. We only have these parametric forms. So what we will have to do is dy dx is going to be, we first have to take the derivative of y with respect to t. So just find the derivative of this. And then since t is a function of x, we will have to find the derivative of t with respect to x. And the product of these two functions will be our result. And we can also kind of see that the derivatives cancel each other over here, but that's not really the correct mathematically idea here. It just works out like that. So dy dt is going to be 3 times e to the 3t. And then we need to find dx dt. So we have to find the derivative of this with respect to t. For that, I will use the quotient rule. So first, the derivative of the top is 2 times e to the 2t. And then we multiply it with the bottom. So e to the 2t plus 1. Then from this, we subtract the top times the derivative of the bottom. So 2 times e to the 2t. And this we divide by the bottom squared. Just like this. And then we need to see if we can just cancel something out over here. So if I just expand this top, I'm going to have 2 times e to the 4t plus 2 times e to the 2t, and then minus a 2 times e to the 4t, and then a plus 4 times e to the 2t. And then this will be divided by the same expression. So what I will have here is, well, this 2 times e to the 4t minus this will just cancel. So I just 6 times e to the 2t divided by e to the 2t plus 1 squared. And then now we just have to go back to this original formula I did over here. So we just need to multiply these two expressions together. Noting that we have calculated dx dt, we need the reciprocal of this. So what we can say now is that dy dx is just 3 times e to the 3t, and then multiplied with the reciprocal of what we have found over here. Just like this. And what if we want, we can still simplify this a little bit. We can divide the 3 by the 6 to get a half, and we can also factor out a e to the t over here. So this will just be a half times e to the t, and then times e to the 2t plus 1. I mean, not sorry, but we can, this 3t minus 2t is just going to be a t. That's not factoring, that's just simplifying the fraction.